7-7 is called determinant of a square matrix. In this section, you're going to learn how to do something called the determinant and then something called minors and cofactors. These are simple tasks. They're a little tedious at the end, but they're overall simple if you know what you're doing. So this is you're going to make sure you give me your full attention, right, Sophia? You're going to make sure you give me the full attention, you practice, and then I promise you this is not anything near like the complicated processes that we were just finishing.
This is easy.
I would say this is easy. It gets tedious, but it is easy. All right, so the first is the determinant of a 2x2. And notice the name on the section said a square matrix. A square matrix is one that has the same number of rows as columns. So we're going to learn how to do this for a 2x2 and a 3x3. Those are square. Same number of rows as number of columns, okay? And in my opinion, like the wording on this slide is a little confusing. The concept to finding a determinant is to take these diagonals and multiply them. So I would multiply A1 times B2 or whatever two numbers are in that diagonal and then subtract from it the product of the other diagonal. So when I first taught this, like, you know, back when dinosaurs ruled the world, I think I drew this one time and the girl's like, it looks like a Jesus fish. And then she was like, if you make the eye, the slit, it reminds you to subtract them. And I was like, you're so smart. So that's how I'll teach you now. You're going to start on the bottom right corner. If you start in the bottom right corner and you draw yourself the little fish, it will remind you the direction that you're supposed to go. So if I had 1, 2, 3, 4 as my determinant, then I would start at the bottom right and go around and up and put the minus there. And that reminds me I'm multiplying 4 times 1 and then subtracting from it 3 times 2. And you literally get one number at the end, and that's your determinant. So -2 is the determinant of this 2x2 matrix. We're just going to do that a whole bunch of times, okay? The way the notation on a determinant is these, like almost like absolute value bars. Those little bars mean find the determinant of this matrix. So it will either say it in words, find the determinant of the matrix, or it will give you those two little absolute value bars, and that's what it means. It means find the determinant of what's inside these bars. All right, so A and B, evaluate the determinant of the following matrices. Oh, I'm missing an R. Never even noticed that before. So what numbers do I multiply together first?
1 and -2.
So 1 and -2, and then minus 5 and 3. And I get -2 minus 15, -17.
I couldn't flip them. How do you stop yourself from flipping them?
Draw a fish. I drew the fish. Well, you have to, the fish? You have to start from here.
Start from the bottom. Do it again. So -1 times -3 minus 4 times 2. 3 minus 8, whatever animal you want to call it, as long as you remember what to do.
-5.
-5, good. All right, now we're going to learn something, focus people, we're going to learn, these are called minors and cofactors. So the minors of any square matrix, so you can do a minor of a 2x2 or a 3x3. We're going to do both. You could do a 4x4, but that's a nightmare. So we're going to stop at 3x3. Is obtained by deleting the row and the column that the cell is named after. So if I go to find, I'm going to start with like just a 2x2 matrix. This would be row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. So if my matrix was, if I start the same one, 1, 2, 3, 4, then I find the minor of each individual cell by crossing through the row and column that matches its name. So if I'm filling this space, or if I want to find the minor of row 1, column 1, then I literally cross out row 1 and I cross out column 1, and the number that's left is the minor. So then I do the same thing again. I go here and I say that's row 2, column, or row 1, column 2. So I cross out row 1 and I cross out column 2, and what's left is the 3. And then I go to the bottom left, pick a different color. This would be row 2, column 1, row 2, column 1. What's left is a 2. And the last one would be row 2, column 2, row 2, column 2, and what's left is a 1. So for the 2 by 2, they're really just switching corners. But in a 3 by 3, it's going to be different, which is why I like teach you to go ahead and cross them out. Then the cofactor takes that exact same thing and it changes the signs on those 2 locations. So the cofactor of 4, 3, 2, 1 is 4, -3, -2, 1. So the top right and the bottom left corners change signs. We're going to go back to the 3 by 3 in a minute. Now the pattern for a 3 by 3.
-4, 2, 10, and -4.
Good. Top, bottom, right, left. Or like your north, south, east, west spots. Those are the ones you're going to change. We're going to do the 2 by 2 first. So there's 4 cells, right? First cell is row 1, column 1. Column 1. So cross through row 1 and column 1. What's left? -6. Then I cross through row 1, column 2. What's left?
33.
Good. Then I cross through row 2, column 1, and then what's left? 5. And then I cross through
4.
Good. Row 2, column 2.
-3, -5.
Good. So that's your minor, and your cofactor, the -6 stays -6, the -3 changes, the -5 changes, the 4 stays 4. Yep. Well, we're going to do a 3 by 3. Yep. Yep. Now we've got a 3 by 3. Think about if we do the same exact thing. If I go to do row 1, column 1, I cross out row 1, column 1, there's no longer just one number left. So we find the determinant of the 4 numbers that are left. Everybody heard that? Yep. So I'm going to make this nice and big because we're going to fill this space. I'm going to make it like a tic-tac-toe board. And this is row 1, column 1 is the first cell, right? So I cross through row 1 and column 1, and what's left is 2, 1, -1, 1. And I'm going to go back and find the determinant of that at the end. I'm going to just write them all out, and then I'm going to go back and find the determinants. Yup. Are you like talking to him? Are you saying hello? What's happening there? Jesus, hi. Thank you for this lovely thing. All right, now I cross through row 1, column 2, and what's left is -3, 1, 1, and 1. And then I cross through row 1, column 3, and I get -3, 2, 1, -1. With me so far?
Yeah.
Now I repeat it for row 2. Row 2, column 1. And I get 0, 2, -1, 1. Row 2, column 2, 4, 2, 1, 1. Row 2, column 3, 4, 0, 1, -1. And then I go row 3. Row 3, column 1, 0, 2, 2, 1. Row 3, column 2, 4, 2, -3, 1. And row 3, column 3, 4, 0, -3, 2. Now I practice the determinant 9 times.
It starts from the bottom right?
Yep, bottom right. So this way. So 1 times 2 minus -1 times 1, which is 3. 1 times -3 minus 1 times 1, -3 minus 1, -4. -1, -3 minus 1 times 2, 3 minus 2, 1. Then I go to the next one. 1 times 0 minus -1 times 2, 0 plus 2, 2. 1 times 4 minus 1 times 2, 4 minus 2, 2. Good. Negative 1 times 4 minus 1 times 0. Negative 4 minus 0. Good.
Negative
0 times, well, 1 times 0 minus 2 times 2. 0 minus 4, negative 4. 1 times 4 minus negative 3 times 2. 4 plus 6.
10.
Good. And 2 times 4 minus negative 3 times 0.
That's 4. Does it get bigger?
No.
If you did a 4 by 4, you'd have to do like, which we'll get to at the end. We're not gonna do those. It would get worse, but yeah. Okay, those are the minors, right? So the process, like I said before, the process is not difficult. It is tedious, I get it. And you have to be really careful with your signs. Now, which of these change direction if you look back? So it stays as 3. Oops. 3, the negative. So this one, this one, this one, and this one are the ones that are changing. So it becomes 4. Then 1 stays as 1. 2 becomes negative 2. 2 stays. Negative 4 becomes positive 4. Negative 4, negative 10, and 8. And those are your cofactors. No. Minors are the majors and minors. Majors and cofactors, or minors and cofactors. And cofactors.
Do I have to do all of that work?
Yeah.
Wait, how many are we going to be on the quiz?
1.
A few.
Yeah.
Do I, like, I have to show, like, one?
So the good news is, well, listen, there is a method to doing what we're about to do, which is a determinant of a 3 by 3 using cofactors. And I used to teach that, and I'm going to teach you another trick, and nobody ever picks that. So we're going to put a big fat X right through the next 1, 2, 3, 4 slides. And we're going to go to example 5.
Bro, it's 7.7.
I'm not going to teach you. Like if you go to YouTube and you search for like determinant of a 3 by 3 using cofactors, you'll find a whole nother process, which is using like similar to what we just used, but then you take it to the next step. And every time I teach it, nobody ever chooses it. So I'm not even going to waste the time on it. I'm going to teach you another way. So this method is one of those things that once I do it, probably once, you will understand it. It's weird the first time, but it is not hard. If you can multiply and add numbers together, you can do what I'm about to teach you, okay? You just have to do it carefully. So notice this is a 3 by 3. So this method works for a 3 by 3 matrix. The first thing we're going to do is duplicate column 1 and column 2. So we rewrite column 1 and column 2 to the right. So negative 1, or negative 2, 1, 3, and 1, negative 1, 1. Obviously, you have to do that carefully because if you rewrite it wrong, the whole thing's wrong from here on out. So be careful there. Okay, then we're going to multiply down a diagonal. And if you think about the order of the Jesus fish, we start which diagonal? Top left, bottom right, or top right, bottom left? Top left, bottom right. So we start bottom right, but we start there, right? Instead of here. So the order goes the same on the 3 by 3 determinant. We multiply these diagonals first. So we're literally going to multiply the numbers in that diagonal. So negative 2 times negative 1 times 0, which is 0. Then I do the next one. 1 times negative 2 times 3, negative 6. Then I do the next one, 0, 1, 1. The zeros in these things are like little pots of gold. Then I go back the other direction. And I multiply those diagonals. 0, negative 1, 3, 0. Negative 2, 1, 4. And 1, 1, 0, 0. Now I'm going to add all the pink diagonals, so all the ones that go up, top, left, bottom, right. I'm going to add those results together. So 0 plus negative 6 plus 0, which is negative 6. I'm going to add all the ones from the other side together. So 0 plus 4 plus 0, which is 4. And then here's the order is important. I do the first diagonal sum minus the second diagonal sum. So negative 6 minus 4, which is negative 10. you'll get one number at the end, just like we do with the fish. But the order of those diagonals is important. So remember, it's the same as your smaller determinant. This is worse than Gosh Jordan.
Okay, no.
All right, so we're duplicating the first two columns. So -2, 3, -1, 1, 0, 2. Then we do these diagonals first, right? So 2, guys, 2 times 0 times 3, 0. 1 times 1 times -1, -1. 3 times 3 times 2, 18. And add them up. Positive 17. Then we go back the other way. Then it's 3 times 0 times -1, 0. -2 times 1 times 2, -4. 1 times 3 times 3, 9. And you get 5. 17 minus 5. 12. Real quick, the other thing is you can check these answers. Open your calculators up. Take your calculators out. So we go matrix. We go edit. It's a 3 by 3, so we type in the original one. -2, 1, 3, 3, 0, 1, -1, 2, 3. Just the original 3 by 3. And then when you go back to the menu that is matrix, and you go arrow over to math, the very top thing is DET, which is determinant. So DET, bring back the letter A is where I stored it.
Wait, where do we go? Apps?
No, matrix, and then math. There is a question on the homework that gives you like decimals in your matrix, but it says use a graphing utility to find the determinant. So you are using the graphing utility. You don't have to do both.
-10.